All right, let's continue. Actually, before I move on, there are two things that I wanted to make clear. The first one is very important. It's the very first time that I actually have my head in the butt of someone. It never happened before, and don't draw any conclusions. It's not a habit of mine. Secondly, I've been asked a question during the break here about the example I used about eventual caches and strong consistent caches. What was I like really not like everything I said was clear to or not clear? Anyone didn't understand it? Should I go over it again? Okay. Looks like I got two guys. I'll guess that maybe there are others that are a bit shy. So let me quickly like explain this. So one of the questions I've been asked is, why am I not creating this cache to be strongly consistent directly? Well, because of the latency implications, right? I want to reduce the latency as much as I can. So that's why, and saying that this example, like as it could fit on on a slide using 3 lines of code, is still about my hotel booking system, right? The biggest use case I got out there is the search, right? If you look at the ratio, there's going to be way more people searching for a room than eventually booking, right? So that's why I created the cache that way. And so the second line of code there, the eventual cache.getKey, is an example of a random operation on the cache that uses eventual consistency, right? Now, talking back to the slider there that I mentioned, where you want to be able to move the slider from base to ACID, like more or less. That's what I want to do there. I want to move it all the way to the right, if my memory serves, all the way to ACID, like strong consistency as much as I can. And so this is probably where stuff was a bad idea of mine. So I create this strongly consistent cache accessor that robs my cache, so basically gives me a strongly consistent view on the data that's inside this cache that was configured to be eventual. And I used this accessor to do a put if absent. And that was probably a confusing bit. I'm trying to be smart here, and I fail, obviously. Trying to use the cache as a finite state machine that says if for this element there, and that's also probably missing, so this element is a compound of the key and the value. And if this return value doesn't return, if this put if absent doesn't return me any previous value, it means that I successfully booked the hotel. Nobody would implement this like that, I hope. I was just trying to be smart to fit a bunch of code with a bunch of meaning that people would automatically infer from those 3 lines of code. And I realized that was a failure. So you could consider this as, I guess the most obvious way to do this would actually to do what the strongly consistent cache accessor does for you, which means robs everything inside logs, right? I log the value for a write, read it, make sure it's still available, book it, put it back to the cache, release the lock, right? That's what this does. Basically, the read could happen using the strongly consistent cache. So I do the get, I get a value that I know is up to date, and now I know I'm racing against other people, but which is most probably fine because chances that somebody else is booking the same room as me is probably low enough, right? And then I can do a compare and swap operation or something like that. Again, I was trying to be smart, covering a use case that actually never implements it. So, as I said in the beginning, take everything I say with a grain of salt. And in this particular case, I have to admit, I have no clue what I'm talking about. I'm booking rooms. I never implemented a system that books rooms. All right. So, what I wanted to do next is take a look at how we can start applying some of the stuff we covered to either existing applications or fundamentally looking at the way we architect a system in a different way, right? When I say the way we architect a system, I'm talking about this 3-tier architecture that you saw previously, right? It's not the one and only way to architect a system. It's one amongst many. Just happens to be that somehow is the one that is applied mostly in the enterprise. Again, in my experience, based on what I've seen. I didn't mention that previously, but before working at Tergata, I actually have been a consultant for probably 10 years or something, implementing a bunch of different systems with big or not data requirement. So I took some random example. I took this website. Anybody knows this website? Cool. So that's apparently the presentation from last year that has the most views. That's probably what I did because that's what's relevant to this thing. So it's building faster websites. Almost, I think, applies to this. I actually didn't watch it, but I think it's more client-side in that case. And what we care about mainly is not the presentation itself, but it's this like third icon there that says amount of views this thing has been viewed 11,000 times. Right? So that means what? That means every time, I guess, I actually have no clue what it means internally, whether people watched it to the end, hit the URL, I don't know. But we're going to be very pessimistic. We're going to say it means that somebody hit the URL, right? I clicked the link to see the detailed view of this presentation, right? So I guess this kind of schema wouldn't surprise anyone. Imagine this sits inside a relational database, so I would expect to have a presentation table that has a primary key, has a title, has a short description, a longer description, blah, 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 God knows what. And it seems very sensitive to put something that's called like the number of views that this presentation got. Right? So what this implies, though, it implies that every time somebody hits the detailed view of this URL, the detailed view for this presentation, that I need to do a write to the database, right? So that's actually pretty write-intensive like use case, right? And if I got it right, this Parlays website is all about viewing presentation, right? So what's the top use case? I expect, I haven't seen the stats, but I expect that people actually go there and watch presentations. So every time I need to increment this counter there. Now the good news is that we don't need to think about all those things, right? We got Hibernate handling everything for us. And actually, Hibernate's pretty smart. Because Hibernate, whenever I will update this value, will actually flush that to the database at the latest possible point in time. So that's cool. It's cool because it means that the latest possible point in time is actually when the transaction commits. So it means that I will not be having data mutated in my in-flight transaction for too long because I'm mutating things and then it's being flushed. Except, actually, if I update this value and then do a query that inside the same transaction that lets me view like the top most viewed things on the right-hand side. Right? I'm actually doing a query that involves, in this particular case, this very field there, right? So in order to execute the query, Hibernate actually has to flush the dirty state to the database so that the query can return a valid result set. So now all of a sudden, I did update that, and then I do other random stuff in my transaction, and transaction lifespan like grows, and potentially other people wanting to read this thing gets blocked and whatever. So that then might be a problem, but it's all easily worked around, right? Make sure you don't do anything stupid, which, by the way, is one of the main issues I have with using an ORM in general. I keep on mentioning Hibernate because that's the one I happen to know a little. But the ORM is a very leaky abstraction, in my opinion. It tries to make everything transparent to you, but actually it isn't really, and it's really easy to shoot yourself in the foot, right? I guess we all did at some point something stupid with an ORM. Who did not do anything stupid with an ORM ever? Never screwed up. Never, ever. I did a bunch of stupid things. A bunch of them. Served me well, right? Serious lesson. You do them once, then you don't do them again. Another potential issue, by the way, is who knows about the open, what's it called again? Open session in view filter of Hibernate? Right. That's awesome, right? I can keep my session open for the entire request time. So it means now that the well, I can actually commit the transaction prior to this. But if I don't, it could be that my transaction commits at the very latest point in time, right? Which is when the last byte got flushed. Generally, since we got Spring in there that does a bunch of other stuff, including transaction management, the transaction boundaries will be well defined to whatever makes sense to your use case. Though generally, I guess, I don't know really, I haven't written an enterprise app for a long time, but I guess I would do this mistake. All right, cool, sorry. I thought I was talking nonsense. And finally somebody noticed. Crap, I lost my thought. Whatever, it was probably not important. Sorry, that was bad. Anyways. So one way to sort this problem, right, because I'm here writing to the system, is actually to shard, right? I shard my data set, so it's the cloud anyways, resources are cheap, instead of writing all the way to the same node, because, right, the latency stuff that we discussed for the eventual consistency applies to strong consistency as well, right? If your node is overwhelmed doing writes, right, let's say it's a platter that rotates and has, you know, this arm, this thing can't do writes in parallel, stuff is sequential at some point, and that becomes your bottleneck, right? Because there are many writes happening, not only to this particular presentation, but like to others, but those needs to happen, blah, blah, blah. It's a problem. Again, databases do smart stuff to avoid too much contention, but it's a problem nonetheless, and writing, scaling writes in RDBMSes is really hard. So what I do is I just split my data set. Say, I don't know, I make all the presentation, I think they call them channels in Parlays. So for Devox 2012 on one node, actually that probably would be stupid. Probably shouldn't do that, because probably like the latest Devox has more hits. So I don't know, I find some awesome sharding scheme to make sure that the data is distributed across multiple nodes. And that helps for a while. And then Parlays becomes even more successful, and despite all the prediction, Java doesn't die, and there are more Java developers that want to learn. That would never happen. Who wants to learn? So, more nodes. Crap. I need to redo this whole process again of finding another sharding strategy. So data, really annoying, really error-prone. If you do a mistake in sharding, by the way, it's really hard to fix after the fact. So, but we don't do mistakes. We're developers. That's the good news. No mistakes ever. It's all test-driven, right? Validates. Cool. Ship it. And so I'm sharding this data over multiple nodes, but then I realized, crap. I got this view, right, that said that using this view, again, that's the way that I decided which presentation to put on there. What is the most successful, the most viewed presentation in Devox 2012? So good reason to not strip, like shard by channel, because otherwise I defeat my own point. I need to go to all the shards, ask all the shards for all the presentation they have, which is say the top 10, because I want to present the top 10, because the top 10 could be on a single shard, which would be bad, probably means that the way that I sharded wasn't brilliant. But I need to go and ask the same question to all the application, to all the servers, get the answer back, and then aggregate my real top 10 result. So that's a very obvious example on how all the sharding logic actually like leaks big time into your application, right? Which is the good news with NoSQL stores. I actually let it's the data store itself that handles that for you. Even though there might be some sharding in place, you don't have to think about it always. And that's a very non-neglectable point. But you need to have the sharding logic at all points, even in mind at all points, even though you could abstract it somewhat. Right? Every time you do a write, every time you do a get, you need to know where to go. And there are tools again for that. I think, again, Hibernate had something around that, right? It was this side project that eventually became part of the Hibernate umbrella, if my memory serves. Anyways, that lets you do this sort of transparently to some extent again. But the query example is probably one where it fails or not. I don't know. Another way of scaling all this is using a queue, because as I told you, every problem in computer science can always be solved using a queue. Queue are just a magic thing. They solve about any problem. I'm being sarcastic, right? Just want to make sure. So using a queue, what I can do is write to the queue, and updates come in batches, and then I decide that based on time and or amount of updates, I actually flush it to the database at some point, right? I could do this like very, in quotes, stupidly. Say that there is a thread per node that sits there and does the update every 5 seconds. So it means that when somebody looks at the latest result or sees a number of views on the presentation, it's at most off by 5 seconds. I could also do this slightly more intelligently using tools that exist. In that particular case, I'm going to cover stuff that we have, but there are other ones, I guess. And that solves also another problem, which is you probably want a persistent queue, right? Even though I agree it's only like numbers of views on a presentation, I don't think the presenter there, actually, let me rephrase this. I was about to say you would never sue if anybody like doesn't watch his presentation, but actually I would sue Stefan, right? Because if there are missing views, I mean, out of the 3 that will be mentioned, there's a 4th one I really want it to be accounted for. It's like 25%. That's not acceptable. So I would sue him. So he probably should make this right. And you can solve this using a persistent queue, right? Making sure that whatever makes it in the queue is persistent. Somehow use a write-ahead log on this so that if the node crashes, when it comes back up, like all the elements in the queue are back. Again, you could use distributed queue, and that's the example I'm going to use, so that if the node dies, another node can pick up the work where this one left off, right, and do the updates. So let me show you, this is, yeah. All right, so I guess is this readable at all? For me, it's not, but I'm old. Everybody can read this? All right, so this says application code. This says cache, and this says RDBMS, so that's my database, right? So a read comes to the web page. So what I do is I update the value in the cache so that a write can also be scheduled for that through a write behind queue in my cache, right? So I configured this write behind queue as being write behind, i.e. not write through. It waits. It batches stuff up, so like people come and view things. And eventually, I got a bunch of views for this particular thing in the queue. And now I can ask my writer to make a single batch update to the system. So this gets delegated to you. The writer is code that you provide, in this case, Ehcache. But I guess any write behind queue would work the same, because you know how to write the data to your system of record, right? So, and I update the database. This sounds all good. Problem solved. Moving on. Though I just wrote to the database, I committed my transaction, and I haven't yet popped things off the queue, and my node died. As soon as I got a persistent queue, again, whatever system, right? It gets a little bit more complicated, as you'll see in a sec when it's a distributed system, but the problem is the same. If you don't have a two-phase commit between your consuming of the queue and writing to and committing the transaction to the database, well, the next time the thing comes up, since all those elements that were still around are still in the queue, right? Whether the queue is passivated on disk or whether it's inside my cluster, as soon as a writer comes up that can handle this again, my message come back in and they're being written to the database again. So this makes me look good when this happens because all of a sudden I got 5 views to my presentation, right? But this other guy there, he just added another 100 on top. So that's not awesome. Again, the example I'm using is it's not necessarily worthwhile the effort to make sure that this all happens sort of eventually consistency always. You could, I guess, live with being slightly off, but it's just for the matter of giving an example. So how do I avoid duplicates writes in the face of failure, right? I want to write that's idempotent. So in this case, in case of a totally distributed system, actually I thought of that yesterday night at 3 a.m., so hopefully I wasn't drunk or anything. I'm pretty sure this works. So you mark every entries as from what node they come from when you queue them for a write, because we're in a distributed system, right? So every node can serve a request to presentation foo, so every node can increment, right? So I know where the write comes from, and then I also make sure when the write happened. And as part of my transaction to writing to the thing, I actually save when I wrote the last thing from node X, right? When I say timestamp, again, use whatever you want. That's why it's in quotes. If you know that your NTP is well-tuned and that time will never go back, if you know that you can rely on the wall clock, use the wall clock. You're welcome to do so. If you want to use a more advanced clocking system, you can. There is one benefit, though, is that we're consuming off a queue. Who says queue says ordered, so we don't suffer from the reordering problem that we talked about in the previous example. So that's nice. But since we're distributed and we're writing data to multiple persistent storages, I need to either be idempotent, right? So basically cover the case where anything can happen at least once. It means that it will happen once, that's for sure, but it could happen twice. See the example I just gave in the face of failure, right? I don't think any system that says that gives you that kind of guarantees happens at least once will actually make things happen twice just to make sure that you implement the proper thing and piss you off. You know, it will do like once, but they can't provide you once and only once. Once and only once in a distributed system is really, really hard to achieve. I'm going to talk a little bit about Couchbase because I play with that a bit and I found it was interesting concepts and used by others as well, so they're not the only one, but I think it's interesting. So what Couchbase lets you do is it lets you insert documents inside the store without updating any indices, right? The point is being able to write as quickly as possible. Right? Now, if you write data that's immutable, i.e., if I take the example of the page view that we just talked about, instead of persisting a number that increments, I'm actually storing that somebody viewed this thing. And actually, that might be the way that they do it. I really have no clue, right? I didn't talk to anyone that worked on parlays, so stuff that I say might apply or might not. I have no idea. But they actually do store who's seen what. Because when I come back to the system and I click on the presentation, like I did for this one, when I did the screenshot, they actually told me you already viewed this presentation. We're going to make the presentation start where you left off. As I must say, I'm really sorry I actually left off at the very beginning, because it was just for the matter of this screenshot. So, but I guess the feature works. So they actually know when somebody goes look at something. And so what they're persisting is potentially immutable data, right? At time t, Alex came to the website and watched presentation foo up until point whatever. It might be that I leave, that I come back, and then I restart watching the presentation, and I move a little bit forward, right? So now I got the choice, what do I do? Do I update the point to which Alex came in and watched the presentation, or do I add an incremental update? Do I sort of write in a append-only way and say that actually Alex came 2 times, and I know this. And the first time he watched it up until there, and then he watched it up until that other point. That is most probably further in the future. And then I can actually reapply this, right? And make the video start wherever I left off. In terms of my page view, though, what it means is that, what does that really mean? It's not page views, it's presentation views. So I guess these 2 visits that I made actually count as 1, right? I'm 1, and I come and I watch this presentation. So I think even though I came 3 times, I didn't watch the presentation 3 times. I watched it in 3 chunks. So what I can do is actually write exactly that in my document store. In this case, Couchbase. I write the thing that Alex came around and did that on that day up until that point, then furthermore. And then I create a view that lets me calculate how many people are in the process of watching or finish watching the entire presentation, right? So the way that you would do this in Couchbase, you would actually write a map function and a reduce function that goes over those documents and actually produce you this result set. Probably this view would end up in something like, oh, that's the presentation ID, and that's the amount of views it has, right? And now, when I insert this document inside Couchbase, actually Couchbase will not update any indices. It's about how like really low latency, right? If you remember what drove like all those NoSQL stores, all we care about is low latency. So we write this as quickly as we can. It's actually awesome. It's not an update, it's an insert, right? In the very example I just took. If we settled on doing it this way, it's only an insert. We're only appending at the end of the thing. Updating is way more complex, as it turns out. So I only do this. And then when somebody queries for the view, actually Couchbase lets you decide how up-to-date the result is going to be that you're going to get. So I actually tell it, I can tell it that I don't care. Whatever you have in the index is good enough. We're talking about page views. I mean, again, right? What's the semantic, especially under high load? By the time I read the value is out of date. So if it's out of date, if it's off by 1, instead of being exact, the transaction committed on the service layer that I wrote that was isolated by a Spring annotation of some kind, who cares, right? It's irrelevant. It's the value that I see existed at some point, and that's all I care. And that some point is probably not too far off in the past. Or I can tell it actually do update if required. So it will see, oh, this index is actually not up to date, so I will rebuild the index. So I will get an up-to-date result. Obviously, in 10 years, the data set will be pretty big in terms of people viewing things, right? So running this MapReduce function will take a long time. Updating the index will take a long time, even though these are incremental indices. So it will just take time. So you probably don't want that. If I did say whatever was there was good enough, though, I can also tell it that even though I told you that I don't care about the latest result, I would be thankful that you do upgrade the index in the background, right? Kind of is the read repair that I talked about for Cassandra, right? I read a value, it's out of date, but actually in the background, the system is going to make it up to date. Or I can just say, whatever, it's out of date, that's cool enough. Now, the way that you could say that this is dangerous, right? If nobody ever queries the thing, the value gets totally out of date. Well, actually, the way that Couchbase does this is you actually now I'm hesitant to say something wrong, so I'm going to say the 2 things, and one of the 2 apply. Either on the per bucket base or on the per view base, you can actually say that after X amount of time, the view should be updated, whatever, or after X amount of inserts, right? Updates, I'm going to call them, right? So I say that this view should basically be recalculated every 5 seconds, right? So after 5 seconds, of being dirty, the view will be recalculated. I can say that every, I don't know, 100 updates, I want the view to be recalculated. And it will do this for me in the background. Again, depending on what I ask, so if I ask, give me the up-to-date result, I want to know the real value and the calculation is already ongoing, it's going to wait for that calculation to end and then give me the result, right? If I say whatever is there, cool. Then if the calculation is done, I get an up-to-date result, or more about, and if the calculation isn't done, well, I get the previous result. And that all enables me to do like really fast writes and really fast reads, if I want to. Beyond that, Couchbase again comes with all distribution and replication stuff, which means that I'm writing documents inside the store, it gets replicated wherever it needs to be. If some node fails, well, it fails, and when another node comes up, it like reheals and stuff, right? That's sort of taken for granted. So I think that's an interesting approach to this problem. There are, and this actually touched on a slight shift in architecture already. And that was the thing that I just said, where you append only, and the data you store is not a counter. The counter is actually an aggregated value, right? It's the sum of all views of a presentation. And the architecture I want to cover here a little is what's called CQRS. Anybody has heard of CQRS already? Cool. Bunch of people, but others haven't. And there are interesting aspects that I think apply there, and some are actually almost disturbing. So CQRS is about all separating really hard the responsibility of commands versus queries, right? And we want them to be two very different things. I guess we all agree on what a query is, and I want to make sure we agree on what a comment is. But so traditionally we do this, which means that there is some UI layer that gets asked to do about anything. There is some conflating things, like, how would I call this, like update and get. Do something to the data and then give me the result. Actually, I must say, like many applications are a weird mix of something and CRUD, right? Which is, what the UI does is it says, all right, give me customer foo. Customer foo gets returned. Customer foo gets displayed in the form gets edited, and then somebody clicks save. And that gets then sent back to my middle tier, and that basically all it does again is probably, I don't know, it's a Web 2.0 app, so it's a JSON stream. And I get this JSON stream, and I again unmarshal it and put it inside my ORM, and then my ORM can do the other marshalling back to some updates inside the database, right? That's really CRUD-like. Anybody has seen this book already? It's a pretty awesome book. It's pretty old, though, in the meantime. And people argue that there are many updates to it. Actually, I must say I'm very dumb. I never found them. As far as I can tell, this book has not been republished. But I could just be wrong. I tried. I got this piece of information from a couple of people recently, and I searched for it and I couldn't find it. So if anybody has it, has that info, I'm seriously looking for it. I was too stupid to use Google. Well, I did use Google, but I'm probably not using the right terms. Anyways, the CQRS stuff will totally not benefit any CRUD application. It doesn't make any sense in a CRUD application, right? What we're talking about here is we want to have commands in the terms of do something that means something to the model, right? So I haven't talked about this, this language that we should all share when we're talking about a given domain model, right? And things emerge, like I'm going to use very stupid example again, but it's like place order, right? There are two things to this. There is an order that's something, that's the domain model entity, and there is an order, and this order being an aggregate, by the way, right? Kind of the invoice, an order contains like order lines and blah, blah, blah. But it's this one thing that we can, not 5 tables, it's this one thing that we care about. And we're placing an order, whatever that means in our system, right? It enters some process. For that to happen, it probably needs to obey a bunch of rules, like I don't know what I could use, like, can I place the order for that? I need to check the inventory, is everything fine, can I, right? And so that's what we're talking about when we talk about commands. We're talking about verbs. Verbs that are in the present tense, and that means something to whatever you do. Crap, I call this like ship order in this case. Same thing, right? There's an order, and I want to have it shipped. And that's a command I give the system. And the system then, basically what I expect as a payload is what are we talking about, right? All right, we're talking about an order, but which one? Which one do you want to have shipped? So that's the information I sent along with this thing. So in that case, I would send the order ID. Another example there is authorized access. I'm modeling a system that does, card-based access thing, right? And when I batch, it actually like, all right, that's fine, this guy can enter. Authorize the access. It's a command. I say something. That's very important. By the way, there was kind of a command when we talked about this, like it's display this presentation or something like that. I'm not sure what the verb is that I would use. I probably should talk to domain experts, and the verb will emerge. But there is this presentation I want to view on Parlay, right? So the command says display me this information. Display presentation, right? That's what I'm asking for, and then that in turn can check, does this guy even have access to the DevOps 2012 channel? Is this fine or whatnot, right? And then do what it means with it. And that's what we want to separate for real. So we want to separate the queries, the thing that says, all right, get me this and display it. Whatever the this is, right? So a query can be something as stupid as asking for the DTO that represents the presentation so that I can do something in the UI. So I can do something with it in the UI, or like complex queries, right? I don't know, like RDA stuff. And on the other end, we want to have our commands that execute against the domain model for real. And one way that the whole CQRS stuff advocates for you persisting commands. Persisting commands is actually like if you want the whole history of your system, right? So example given of the view thing in 10,000 years, that's probably far off. In 10 years, there's going to be a bunch of views, there's going to be a bunch of information, right? I don't want to rebuild my state of my application based on the history of whatever happened since ever. So stuff you can do is called snapshotting, right? Where basically you know what the object state was at a given version. Whatever that version means, and while you're snapshotting, other incremental updates can come to the system, it's fine, right? You just say it's that version, it fitted that, say that timestamp, I don't know, this morning at 10, the state was that, and as a result, like presentation foo had that many views. And all the additional views that come after that will just queue up, and the next time we do a batch to do a snapshot, those will be included. So I can now only reload the snapshot and apply the deltas, and I get an up-to-date model, right? Another thing that's interesting in the CQRS stuff, as soon as you got those comments actually trigger events, right? Again, same thing, an event is something that happened in the past, right? So in the wording, it's something like page viewed event. Same thing probably as the payload of what presentation viewed, what presentation was viewed. And that event actually is being propagated to another store, that's the view store. They don't share anything. And that can then update the view store, again, incrementing a counter, for example, right? So that's this all looks like. That's there, the blurriness maybe doesn't help us. So what we have here is, that's our client that sends commands to our remote facade that delegates to application services that use the domain object to do something, right? Grant access or something like that. The return code here is either ACK or no ACK. So it either works or it didn't, right? Grant access again, same thing. If you don't have access, that says, sorry, no, not gonna happen. Otherwise, it happened, it's fine. So this all goes in here, and eventually it's being persisted, right? I'll get to a couple of gotcha in a sec. On the other end, when I say, for instance, here I query and say, so I want to know all the people that are inside the giving room because we granted them access to and they didn't walk out, and we didn't grant them exit rights. So I query the thing, and this is a very thin layer at this point, right? All we care about doing is, again, hitting some remote facade to do, I don't know, some JSON marshalling, and then a very thin layer that basically exposes directly the DTOs that represents the view that we're talking about. So this is very low latency again. Views are pre-calculated. There is no complex queries to resolve on anything. And again, if you apply here intelligent stores, you can actually scale this out pretty big. So what we have is, again, whatever applies here eventually makes it here. You could use, though, your good old relational database as being the store on the left-hand side, right? And you could have the thing have presentation tables and what have you. That works, right? As long as you publish the events like the way we said that this presentation was viewed, you can still apply the incrementing counter on the query store, and you can store things in an RDBMS. Now, I don't think like the CQRS defenders would be too happy you doing that, but I'm pretty sure this would work. There is one gotcha though, again related to phase commit. We're writing data to multiple things and say we got this queue that enables me that whatever I write to the store, this event needs to be pushed to the query the query store, right? And most probably that's again gonna involve a two-phase commit. And that's not awesome, or anybody who has worked with two-phase commit. If you can avoid them, I would say avoid them. Your mileage might vary. But if it's a pure common store, something that really persists the commands that were applied to a given model in order, the store itself can act as a queue, actually. And what you can have is a process in the back of your store that looks at the store. If the store is event-driven, it can tell you when update happens so it does something. It could be already built in, right? If it isn't, well, you can have a batch thing that basically goes to the store at all times, try to figure out the diffs, and push them as events to the query store. Makes it easier in terms of, again, scaling this thing and avoiding distributed system gotcha. Going for something like that also enables a bunch of things. First off, even if you do the snapshotting, you can always replay the world like to its current state. That's pretty awesome because actually if at some point somebody comes up with something that you never thought of. Like for instance, I want to know in parlays, on average, how many times somebody comes back to see a video, whether comebacks means whatever that means in that question. Whether it means like in how many times on average somebody watches a video, like in how many chunks, or how many people, what videos are the most reviewed. And that was not accounted for initially, but that's fine now, because I can replay the world and gather all the information I want, recreate other views if need be, and I can get to all the information I want, because the system just represents what I'm basically replaying the system, right? I'm replaying the past. That's pretty awesome. It actually also enables, like, it's a perfect match for complex event processing. Because those events we talked about are really the ones that probably your business cares about, right? They are actually the events that the very wording of them, you actually defined with them. And right, what this, for instance, enables you is to actually, based on an event stream, like analyze it, do stuff, and base decision on that, right? So I got two examples here. Say, talking about this card ID system again. Say this is the card ID system to give entry to the subway system. I can, in complex event processing stuff, so they have a language for that that's covered in the next slide, I think. Actually, no, I'm lying. Right? Rules are expressed in an event programming language of some way, where I can say, when a single ID card is used to gain entry twice in less than 10 seconds, right? Probably means that I want to alert some security because somebody's probably, we're piggybacking, right? So I badge in, then I hand the card to you, and you badge in again right in our back. And we don't want that to happen, right? So I can then create another alert of some kind of whatever that means to alert security, I don't know. But the important thing is that the authorized card event, it's all in the system already, right? All I need to do is have another listener for this thing, like my multiple views, for instance, that already exist in the view store. Another example, say when 20 emergencies occur within a 60-minute window and response capacity is over 50% within 100 miles, we want to alert other district that, say, that's fire alarm, right? There are so many fires around that we're actually getting close to threshold, so that if a big fire happens, we will need to call people in from other districts, right? You don't want to figure this out when the house is burning, right? So I live in Montreal in North America. The way that the houses are built there is wood, right? And when anything happens, the first guy on the spot always the fireman. And they just take control of everything, because otherwise you got an entire neighborhood that burns down, right? So you don't want to be figuring out, oh hell, we don't have anybody to send for this fire anymore. Crap, we should start looking around who we could dispatch, right? You can do those kind of things. Talking about velocity of things, there is an interesting aspect, is that, so we moved to a big data age of some kind, that means that all of a sudden actually even reference data has become big data. It's something that we experience a lot at Terracotta, because so we do this thing that lets you access up to terabytes of data on a single machine from a Java process. And as it turns out, so when we talked about velocity of data, right? Data that flies in like really quickly. This is like event, again, sort of based data, right? I don't know, like an authorized payment, payment authorized event comes around on a credit card system. And we want to do some fraud detection of some kind. But doing the fraud detection requires me to access a bunch of data. That is called like this data at rest. But as it turns out, this data at rest cannot rest on disk, because otherwise I will never get my response in time, right? So I got an example there that says, that sounds really marketing-like, but actually I like it. Because for once, it's stuff that means something to me, like something that's applicable to my daily life, right? So the fraud detection for a big company out there, by being able to have all the important data in memory, went down from 45 minutes to 4 seconds, right? 4 seconds most probably is too long as an SLA to actually have the transaction like pending for that long, right? But it's stuff where all of a sudden you could start doing alarm system and actually like prohibit the guy to walk out of the store with a 60-inch TV that he just bought using my credit card for $3,000, right? That's a change. Stuff for profile analysis, right? So let's not be fooled. All those awesome like social networks, they actually care about what we're doing, right? Not only the NSA cares. And they want to profile us, right? And based on all the events that come around and whatnot, so that, I don't know, Google can send us ads. I have no idea what Facebook's business is, but whatever they do. Same thing, right? Being able to analyze this, like matching events versus data at rest, data that doesn't change so much. I'm Alex Naps, I'm a male, even though I got my head in the butt of another guy. I have no plans on changing gender anytime soon, or changing name, or when I'm moving, it doesn't happen so often, right? So that's all this data at rest, but this might be very relevant information, right? Knowing that I'm a good-looking, 40-years-old guy that lives in North America makes probably me a good consumer target for whatever services some people try to sell me, right? So being able to access all that data really quickly is important so that people can make decisions really fast. And I need to buy stuff, and we all need to buy stuff. All right, another thing, another totally different architecture that came up is this thing called the Lambda architecture. Anybody has heard of this? It's made lots of noise, I must say. And I actually heard mainly its name, and eventually I had to dig in a little bit. I thought it probably would make for a fair enough example here. The book is in early access programs, so you can't read everything on it. And I must say, so I never applied any of this, right? I'm not the point here not being me, telling you that's the way you should architect. By the way, I'm not telling you to architect any application anyway. I'm just trying to show you other ways of doing things. And that's an interesting one. So first off, it builds on this notion that a query is a function of all data, and I certainly agree with that. But where all data is immutable data, this thing that just, this page was viewed, this is never going to change, right? I keep on saying this page because that's actually the example he uses in the book. But this presentation on polys has been viewed, right? It's never going to change. I can't go and say, oh, I never saw that. I swear. Even though I do ask my kids that sometimes when we watch TV, and I'll send her the scene, right? I said, just pretend you never saw that. Especially never tell your mom you saw that. That was a mistake of mine. Don't bring mom into this. I'm going to be in trouble. So the two guys writing about this are Nathan Martz and James Warren. Nathan is the creator of Cascalog. I actually don't know this thing, but it's a closure-based query language for Hadoop. And he's the creator of Storm, right, which makes for all this stream processing and whatnot. So the Lambda architecture aims at being. This, again, sounds, sorry, a little bit too much like a marketing slide, but these are seriously fair goals to aim for. Robust and fault tolerant, I guess we all want that. Low latency on reads and updates, right? This is a recurring subject in data persistence. Wants to be scalable, that's awesome, right? Being able to add nodes easily and scale out as need be, because that's all the bad that we can wish for, right? We want to create the next big service that's going to grow and that's going to become the next Facebook. Now, I'm not saying that everybody should architect its apps like it's Facebook, but sometimes not having to restart from scratch just because, oh man, crap, I went for this RDBMS because that's what I use. But actually, I must say, I didn't put so much thought into it. I just used it because that's what we use, and now I need to scale out and it's not possible. Or I need to go see Oracle and put a whole lot of money on the table, right? I mean, that's kind of sad. It wants to be general purpose. Love that. Extensible, so you can extend it to do whatever is the thing that you want to do. Kind of falls a little bit into the generalness of it. Allow for other queries, right? So not go for something where all of a sudden you're stuck to that very amount of queries. Minimal maintenance, I love that one. Debuggable is certainly not neglectable neither. And the way it tries to do this is by building on 3 layers. So the speed layer, the serving layer, and the batch layer. So what these do is that. So I got all my data, and I'm running a batch layer on all that data that does probably incremental updates so that I get batch views. So actually, this is kind of comparable to what I've described with Couchbase, right? So I got a huge amount of data, and I want just to query that data, but I know querying it will take a long time, so I want to have the result like pre-ready. The problem is that on large sets of data, getting that result, so spawning a MapReduce job over a huge cluster, is going to take some time, right? So obviously, in the meantime, I can't stop the world, right? I'm saying, oh, you asked me for that, so please don't do anything anymore because I'm trying to answer a question for this manager there that needs a figure to put in an Excel sheet, so sorry, digressing. So it's going to, all those batch views are going to be out of date. So the service layer actually lets you query inside those batch views now. So I can go and query stuff. So again, say I got a view that lists all my presentation IDs to views. I can go and look into it. And every time a batch finishes, like this thing gets updated, and it's being available for me to use. Again, an update, like a batch, could take hours to finish, right, on certain views or on certain data sets. So what we need now is a way to merge all that so that I get an up-to-date result. So their proposal is to use what they call a speed layer, where then I can fetch those results, merge them, and give sort of real-time view into the system. So that's how the whole thing sort of looks like. I got all my data that's coming in. The data is being fed to two systems. It's being fed to the big, say, MapReduce, Hadoop thingy that will run the batches. So the batches are basically a while loop, right? It's just do this. When you're done, do it again, because by the way, it's out of date already, right? So we keep on doing this. That updates my batch views. And when a batch is finished, actually, we also tell the speed layer to flush. Whatever you had, forget about it, right? Because it's now included in the latest batch that I pushed. But whatever's going to happen after that, now you need to account for again. So whatever happens after the time this batch was successfully processed, the speed layer is going to account for. And it's going to update, right? Oh, that's not really readable again, right? Sorry about that. So that's just all data, right? Everything gets pushed through here. I move this thing inside this huge Hadoop thingy. I have my batch layer that runs in a while loop, updates all my batch views. The data flows through inside my speed layer, like keeps the real-time view, but the real-time view starts whenever the batch view there was last published, right? So if it's kind of the snapshotting thing that I talked about, and then the other CQRS, right? It's except that you only keep the latest stuff, and you keep on running like this. And then when I got my queries, we basically merge everything, right? And those queries or views are basically how would I say? Views on your data, all right? Again, example given like the presentation ID to amount of views, right? Now, one important factor here is, again, is what we call data. And what we call data, or that's, I haven't read the entire book because I can't read the entire book. But it's still all thing of like immutable data, like the stuff we discussed in the CQRS approach, right? You want to have data, it just remains true whatever, right? My current address is the last address that I moved to. The sum of all presentation views, it's kind of a weird wording, is the page view number that needs to be displayed next to this nice icon there, right? This is all derived data. Think back about, there are all queries, right? There are all functions on this data that itself is immutable. It doesn't change. This thing has been viewed again. I won't do the joke again, but once you viewed something, you viewed it. You can't undo this. You can't undo the past. Even though McFly might not agree. So, all right, so that's been a bunch of different things. So what do you do now with all of this? Well, The main goal of this presentation, and hopefully I succeeded, was to make it clear that one size fits all. Actually, I guess we all will agree on this. Actually, doesn't exist. So RDBMSes make sense. Those NoSQL store make sense. I think it's important for you to go out and play with those things, to get to know them and understand them. And that will probably take more than 3 hours sitting in a very comfortable chair on Monday morning on a public holiday. Thanks a lot. But there is just no one size fits all. So I think, my take is we got put into a box and we sort of totally forgot to think out of it. RDBMSs are great for like stuff the data that goes to die, I think, which isn't necessarily a bad thing. So that leads me to my conclusion slide. And yeah, I think we all agree RDBMSs have been de facto way to store data. But, and I think sometimes for a while already it hasn't necessarily been the right tool, right? Doing too many transformations, right? Remember this example I took where basically we want to serve JSON, but nonetheless we get the JSON in, we use Jackson, whatever. There are recipes for that on the web, I think, right? To transform this JSON representation inside my domain model that's actually not the domain model, but DTOs that are annotated with a bunch of JPA annotation along the whatever is the other annotations for doing this unmarshing from JSON, and then I can transparently move all that data inside this thing, and then I can flush it to the database. Why are we doing this? What's the meaning of this? Honestly, I don't get it, but I gave you the heads up, right? I'm not the brightest guy on earth. We should have making the data center not cool down. That makes sense. Keeps your CPUs busy. Sometimes the data model is way too stringent again, right? It's just, all right, I'm stuck with those tables, with columns, fixed amount of columns, with very well-defined types, right? Who's the last guy who's seen a table that has, a database that has a single table with a single column that's a blob? Right. Oh, we need to talk. I want to hear the story. Hey, seriously, why? Use files. But RDBMSs are cool for a bunch of things, only means that they will scale writes badly. And because of their own thing, like the way they work, and yes, they're a replicated database, and so they become very easily a single point of failure. Which again, all those things, you could all negate them to positive values, right? Depends on the use case. And I think now in the meantime, those other data stores, though, they've matured a lot. I think they address some of those issues I have on the other side. And again, I think it's really important for you to know that they exist, look into them. I would even go as far as I would say, like for each type of NoSQL data store, I would encourage you to look at least into 2 different ones. I know it's time-consuming, but there are lessons to be learned. Hopefully the sole CQRS stuff also made it very obvious that there are other patterns to access your data that exist than the one that we've been applying mainly for a long time. And I think the most important bit, and I really believe in this, I think we should all be lazy. We should all be doing the minimal amount of work. Everything will be thankful for that, right? Doing less is quicker. Doing less requires less maintenance. Doing less is much easier to understand for somebody that joins your product or your team or whatever, right? Reading 100 lines of code is not easy. So, yeah, my conclusion is be a polyglot in terms of data persistence, look at what exists, think out of the box, and do awesome stuff. So that's what I had. We have another 12 minutes. So if anyone has questions, I might be able to answer them. Otherwise, that's it from me. Thanks a lot for coming this morning.